Okay, so today we're going to be going over asymptotes. Okay, now it's a kind of a fun word to say, and it looks a little bit complicated based on what I have on the board, but sit tight, you're about to learn a little bit more about these things. Okay, basically by definition, an asymptote is a line that continually approaches a given curve, but does not meet it at any infinite distance. And you're like, whoa, what is this crazy definition? Let me explain, I've got to break it down a little bit. A line that continually approaches a given curve. You should all know about lines because you studied them in Algebra 1, Algebra 2, y equals mx plus b, x equals some number. You have a line. It shouldn't be that difficult. You guys should understand lines. That continually approaches a given curve. Okay? Well, I have an example right here. We have these curves here, and there could be lines. You can kind of see that there's lines that approach these given curves. Okay, like there's this line right here that approaches this curve right here. We're going to talk more about this example in a little bit. So it's not that hard to imagine. You have a curve and there's a line that's kind of approaching it. Okay? But does not meet it at any finite distance. Okay? That's really important. At any finite distance, it never is actually going to cross it. They're never going to meet. And what's important about saying the whole finite distance thing is because it does actually reach it at infinite distance. Okay, if we could actually reach infinity, you would actually reach it. It would actually cross. But since we can't, you have to write at any finite distance. Okay, let's look at our example here. It's one of our parent functions. F of x equals 1 over x. Okay, and as you can see, I have it in blue here, and in the black right here is just the x and y axis. Okay, as you can see, it kind of goes like this, and it curves up, but it never actually reaches x equals 0. The line x equals 0 is right here. And it never reaches it here, or it never reaches it here. Now the reason for that is you can't divide by 0. I can't put a 0 into this function and actually get a number out. It would be undefined. So there would be a line, x equals 0, that would be considered our vertical, because it's going up and down, asymptote, because it will never reach it. Okay? So that would be one of the lines. You can also have horizontal asymptotes as well for this function. Okay? As you can see, it's curving down like this, it's curving over like this, and it's actually never reaching the line that goes right here. Okay? That's because we're going to a bigger and bigger number or a bigger and bigger negative number, either way depending on what way you look at it. And you can't, if you divide by a bigger and bigger number, or bigger and bigger negative number, or smaller and smaller I guess I should say, you'll never actually reach 0. So this line right here is approaching 0, but it's never actually reaching it, because this top number is 1. It doesn't matter what you divide by, you'll never get 0. The only way to get 0 through division is if the numerator, the number on the top, is 0. Otherwise, you'll never get 0. You can just keep dividing it by a bigger and bigger number, just get smaller and smaller and smaller and smaller and smaller and smaller, but you never reach 0. Okay? But if you could go to infinity, if you can plug an infinity in there, then you would actually reach 0. But again, an asymptote is at any finite distance. So you're getting infinitely closer to it, closer to that 0, but never reaching it. Here you're getting infinitely closer to the 0 here, but you're never actually reaching it, because you're going to infinity here, or you're going to infinity this way. So, the asymptotes for this one, vertical, x equals 0, horizontal would be y equals 0. Now this is easy to understand kind of with this function, this parent function, but you're going to get these rational functions that are a little bit harder, where you have to actually involves more thinking to try to figure out what the asymptotes are. So I'm going to give you kind of a general idea on how to figure those out. So say we have a general rational function right here. N of x divided by d of x. Numerator divided by denominator. Remember, these are both polynomials. So this is just our standard rational function. Okay? To find the vertical asymptotes, all you have to do is when it's x when d of x is equal to 0. So you would have to set this bottom function, this d of x here, equal to 0, and that would be the vertical asymptote. It's whatever the x is when you solve for 0 down here. Okay, so let's actually look back at our example to kind of prove that this is true. Okay, 1 over x. Well, it says when d of x is equal to 0. Well, it's x right here, so it means x equals 0. And x equals 0 was our vertical asymptote, which we talked about right here. It makes perfect sense, so this works. Okay, again, I know this one's easier. This is an easier function to deal with. You're going to get harder ones, though, but this will come in handy. For vertical asymptotes, it's x when d of x is equal to 0. It's going to look like x equals some number. In this case, it's x equals 0 for the vertical. Okay, then you have something called a slant or a horizontal asymptote. It's horizontal if it's like this. If it's at any angle, except for up and down, it would be a slant asymptote. But anyway, to figure this out, it's just, it has the equation y equals whatever the limit, if you remember limits, our last video was on limits, of f of x, this rational function right here, as x goes to infinity. Okay, so let's test that with our example that we have over here. Okay, if x was going to infinity, you would have 1 divided by a really, really, really big number. And the limit of that really, really big number, as it's going to infinity, would be 0. So in this case, it would be y equals 0. And we actually got y equals 0 when we were just looking at the graph. So these two things will help you with figuring out the asymptotes, vertical, slant, and or horizontal, of rational functions. If you have any questions, let me know.